Let's start by defining what WebRTC is. WebRTC simply stands for Web Real-Time Communication. It is an open standard, and with it one is able to add real-time communication capabilities to a web application. It provides support for the exchange of media, specifically video, audio, as well as data. With these capabilities, you're able to build very powerful applications. It's all dependent on your imagination to come up with use cases. All modern browsers provide support for WebRTC, and this support in all these modern browsers is provided as regular JavaScript APIs. The flow to make two peers communicate is pretty straightforward. Simply get access to media devices, open peer connections, discover one another, and once connected, you start streaming. Let us quickly visualize the flow. So I have a very simple diagram here, which shows two peers, peer A and peer B, and the goal is to establish a connection between these two peers. However, as per the flow, we first need to get access to the media devices, and assuming that we have done that already, these two peers will need to know how to find one another on the internet. And the easiest way is to have a mechanism where each peer can share relevant information required to make direct connection between them a success and allow media to flow securely. And this is pretty much what signaling is, and introduces the need for a signaling server. Let us quickly go through the flow. So this is our goal, the exchange of media between the two peers. But obviously, we cannot do that without first discovering one another. So let's start from the beginning. The very first thing to do is to gain access to the media devices, that is the camera and microphone. Once we have the access, step 2 would be to share some relevant information. So we send that information to the server. That's step 2. Peer B will do the same thing. So step 1, step 2. Once the exchange of info is successful, we can then establish a direct connection between the two peers, and the transfer of media can start. This relevant information we mentioned up here is the ICE and SDP. Okay, so what is ICE? I'm going to read from WebRTC.org, which says, before two peers can communicate using WebRTC, they need to exchange connectivity information. Since the network conditions can vary depending on a number of factors, an external service is usually used for discovering the possible candidates for connecting to a peer. This service is called ICE and is using either a STUN or a turn server. STUN stands for Session Traversal Utilities for NAT and is usually used indirectly in most WebRTC applications. Turn, on the other hand, which stands for Traversal Using Relay NAT, is the more advanced solution that incorporates the STUN protocols, and most commercial WebRTC-based services use a turn server for establishing connections between peers. The WebRTC API supports both STUN and turn directly, and it is gathered under the more complete term Internet Connectivity Establishment, ICE. The flow diagram we showed earlier is actually not complete. In order to gather ICE candidates, we need a STUN server. We will need to provide these servers in the configuration of our connection. Then the underlying WebRTC framework will use these ICE servers to gather candidates for connectivity establishments, and these are the ICE candidates. So now the ICE candidates becomes part of our relevant information that is sent to the other peer via the signaling server. In our hands-on exercise, we're going to use publicly available stun and turn servers. SDP, which stands for Session Description Protocol, is a protocol that is used to describe the media communication session. It's a key value pair string-based data that contains information such as peers, audio and video codec, etc. Let's go back to our flow again. Let's assume we've got access to our media. We have configured our stun server for the sake of gathering ICE candidates. The same thing has taken place for peer B. Now, assuming peer A is the one that starts the request to connect, peer A will need to generate what is known as offer SDP. We then send the offer SDP to peer B via the signaling server. Peer B will take the offer SDP and generate an answer SDP and send that to peer A. When the exchange is complete, an attempt to establish a direct secure connection will be made. Once that is successful, media will start to flow. In previous video, we briefly mentioned stun and turn servers. We know that two peers on the same network can easily establish a connection. However, when two peers are on different networks, they may be behind a NAT. In this case, they need to go through NAT traversal. NAT stands for Network Address Translation. Now, in order for a peer to know its public IP address, we will need to introduce a stun server. Now, assuming that we have configured WebRTC with stun server as one of the ICE servers, WebRTC will send a request to the stun server asking, "Who am I?" Stun server responds with a public IP address and port the client is on and the type of NAT. The same thing for the other peer. We then go through that process of generating the offer SDP and sending the offer SDP via the signaling server. Peer B, using the offer SDP, generates an answer SDP and sends it back to peer A. In a situation where at least one peer is behind a firewall, direct connection between the peers will not be possible. In this situation, we need a turn server to act as a media relay. So now media flows through the turn server. In this course, we are going to use the mesh topology. Basically, when there are two peers, you have one connection. Adding a third peer gets you 3 connections. 4 peers means 6 connections, and so on. The formula is n into n-1 divided by 2. So if we had 5 peers, it will be 5 into 4 divided by 2, which is 10 connections. Adding the 5th peer, we get 1, 2, 3, 4, plus 1, 2, 3, 4, 5, and 6 equals 10. For good quality and overall satisfaction, it is recommended not to go beyond 4 peers. Now, in this course, we are only going to use the mesh topology. The other topology to consider is the star topology. In a star topology, you can make use of an SFU or an MCU. SFU stands for Selective Forwarding Unit, and MCU stands for Multi-Point Control Unit. In either of the instances, a peer always connects to a dedicated server, either an SFU or an MCU. WebRTC defines 3 main APIs, one for media capture, camera and/or microphone, the other for establishing a connection for the exchange of video and audio, and last one for data channel. To start, we need to gain access to either camera or microphone or both. And to do that, we use the media stream API, specifically the get user media. PeerConnection provides support for establishing direct connection between peers. The API is RTCPeerConnection. And the third API for data channel is RTC Data Channel. RTC Data Channel API allows for bidirectional data transfer. In our hands-on section, we shall apply all these APIs in practice. Now that we are done with all this boring stuff, let's move on to more interesting things. Let's go to code. Hi and welcome back. We are now going to start writing our WebRTC application code from scratch. In this video, we're going to start with requesting media from the capture devices. And in subsequent videos, we will attempt to establish a simple peer-to-peer connection and exchange media between them. This will be based on two peers only. As we had mentioned earlier, throughout this course, we will use React.js to build our client-side application and Node.js for our server-side implementation. Now, without wasting any more time, let's start by navigating to reactjs.org and create our application. Okay, so let's click Get Started. Go ahead and click Create a new React app. Okay, then let's scroll down to Create React App and copy npx create React app my app. Let's open our console and paste the command. I will change the name my app to web. Now I have already created a folder called WebRTC, and I'm creating my application inside the WebRTC folder, which I call web. Now this will take some time. Okay, so we're done. Now our application has been created. Let's make sure that it is working. Don't forget to change directory to our new folder and then yarn start. Okay, our application is working. So the application is running on localhost port 3000. Okay, let's now jump to code. Okay, so let's start by cleaning up. You'll find the code under src, and the file that we need to make changes to is the app.js. So I will go ahead and clean it up. I'm going to add a button. On click, I want it to call a method that will request access to the media devices, the camera and microphone. So for now, just going to leave it empty. And then we're going to add a video tag. Set it to autoplay. Let's create a method that will be called when we press the button for requesting to access the media devices. I'm going to call that getUserMedia. We need to specify what type of media we want to access, and these are specified as constraints. So for now, I will not need audio because it might interfere with my recording. So I'm just going to request video. Hence, I'm setting audio false and video true. Now to make the actual request, we use navigator.mediadevices.getUserMedia, and in that we pass the constraints and we use promises. If successful, then we get a media stream. Else, we catch the exception. If we get an exception, let's log out that exception. And if we are successful, we need to somehow display that stream. For that, we are going to use React's useref hook import. We'll then assign this to video ref. And finally, when we receive our stream, we will assign the stream to the local video ref SRC object. But before we can test, we need to update our onClick method of our button by calling the getUserMedia method. Okay, so let's go ahead and test. Press the button. Oh, nothing happens. I misspelled. Should be autoplay. Let's try again. Voila. So we have media flowing to our browser. Remember when we talked about the three main WebRTC APIs? Media Stream API is one of them. And getUserMedia returns a media stream. Let's get some definition on media stream. So it says, the Media Capture and Streams API, often called the Media Streams API or simply Media Stream API, is an API related to WebRTC which provides support for streaming audio and video data. It provides the interfaces and methods for working with streams and their constituent tracks and constraints associated with data formats, the success and error callbacks when using the data asynchronously, and the events that are fired during the process. If you scroll down, media stream objects have a single input and a single output. A media stream object generated by getUserMedia is called local and has as its source input one of the user's camera or microphones. Okay, now here we've used promises, but you could opt to use async and await. Let's see how we can do that. So I'm going to declare this method async. I'm going to comment this out and copy this line down here and assign it to a const called stream, and then copy this line, paste it down there. So basically, and of course declare this await. Basically this line will only execute if this succeeds. Let's test it out. And there we go. However, I'm just going to stick with promises from now on. In this video, we have achieved our goal, which is to capture media from media devices, in this case, video, and display it as a local stream. Hi and welcome back. In our previous video, we managed to gain access to a video stream using the getUserMedia API. And what you see on the screen is the result of the code that we wrote. So let's do a quick recap of what we did in the previous video. We first created the button and video elements, and then we created a method that, when called, will make a request to the media devices by using the getUserMedia. We passed in the constraints and specified that we needed video and not the audio. And when the request is granted, a video stream is returned, and then we assign the stream to the SRC object of our local video ref that we created using the React hook useRef. Now, in this lesson, we're going to see how signaling works, and we will solidify our understanding by doing it manually, step by step. In a previous lesson, we mentioned that in order for two peers, peer A and B, to establish a successful connection, relevant information must be exchanged. That relevant information is the SDP and ICE candidates. In order to generate this SDP, we need to create peer connection using the RTCPeerConnection API. Once we've instantiated and created the RTCPeerConnection, which we call PC on either peers, and assuming peer A is the one that is offering to connect, we use the PC to generate the SDP. And then we set this SDP on peer A as local description. And then we copy it and set on peer B as remote description of the peer connection. Now, having set the offer SDP as remote description for peer B, we will then generate an answer SDP, which we shall set as local description, and then copy it and set on peer A as remote description. We will do the same process for ICE candidates. We have seen how we are going to exchange SDP and ICE. Let us now go back and do the same in code. I know that I'm going to have two peers, so I will need two video elements. And I will need a ref for the remote video, similar to this. And declare it. Let's go ahead and resize our video elements. This will be our local video, and this will be our remote video. Remember, we mentioned that we're going to do the exchange of SDP and ICE candidates manually. We are going to create some buttons. This one will be for creating an offer SDP, and this one will be for generating an answer SDP. Then we'll have a couple more buttons. This one will be for setting remote description, and this one for adding ICE candidates. Go ahead and create these buttons. Let's add the buttons that we just mentioned. I will copy this and create answer. Let me just copy these ones. Let's change our code slightly by calling the getUserMedia after our page loads. This means we won't need to press the button to access local media. For this, we're going to make use of the React hook useEffect. So let's add it. Let's implement the useEffect. And let's move all the code inside getUserMedia into useEffect. So I'm going to copy this. If you get an error, make sure to restart. Let's also make sure that the useEffect is executed only once by adding empty dependencies. Okay, so let's go ahead and test without pressing a button, just by refreshing. The expectation is that the local video will be displayed. There we go. So it's working. I didn't have to press the button. Now I can go ahead and remove this button here. Everything should be okay. We had mentioned earlier that for a connection to be successful, we need to exchange SDP and ICE candidates. In order to generate the offer SDP or answer SDP, we need a peer connection object. For that, we need to make use of the RTCPeerConnection API. Here there are two peers. There's one connection. So each peer will have one peer connection. However, if we had a third peer, that increases the number of connections, then we would have to create two peer connection objects per peer. Go ahead and instantiate a new peer connection. Define a couple of event handlers, in our case, on ICE candidate, in which case the event will be raised when a new ICE candidate is available. For now, we will stringify the value and log it to the console. And on track when we receive tracks from remote peer. This event here on ICE connection state change helps check the connection state of our peer connection. Possible values are connected, disconnected, failed, and closed. Let us now create a variable that will be used to assign our peer connection. We had mentioned that we're going to manually initiate the generation of SDP by using these buttons. So let's go ahead and create the on-click methods. We don't need getUserMedia method that we created earlier on anymore. So let me just remove it. We can then create our on-click methods, create offer. You don't really need to initialize the peer connection here. I just wanted to have IntelliSense when using the variable pc.current. If the call to create offer is successful, we will get back an SDP. Offer to receive audio and video are optional and you don't have to use them. Once we get the offer SDP, let's go ahead and log it to the console. And as discussed before, we're going to set it as local description. Now the method createAnswer. You will notice it's exactly the same as createOffer. So we are going to copy and paste the same code. Replace createOffer with createAnswer. Now let's add the method calls to on-click events of createOffer and createAnswer. Okay, let's go ahead and test our createOffer method. Okay, so we have our local media. Let's go ahead and display the console because according to our code, we're going to print out the SDP on the console. Let's clear the console and then click the createOffer button. We get the SDP of type offer. And we also get a list of ICE candidates printed out, which we shall make use of when we add ICE candidates to the peer connection. Now, assuming that this is peer A and this is peer B, we have just generated an offer SDP. We will take it manually and set it as remote description, and then we will generate an answer SDP and set it as remote description on peer A. So let's go ahead and do that. Let's add the remaining methods for set remote description and add candidate. We shall use a text area to paste SDP and candidate values, and for that let's create a ref for the text area. Let's go ahead and add a text area element and set its ref to text ref that we just declared. Now that we have text ref, we can grab its value, in this case SDP, and parse it into JSON representation and set the value as remote description. Let's go ahead and update the on-click event for the set remote description. We will do exactly the same for add candidate method. However, in this case, we will use add ICE candidate method of the peer connection object. Finally, let's go ahead and update the on-click method for our add candidate button. Okay, so we're now ready to test our manual signaling. Okay, so as we said, assume that this is peer A. Let's load another tab. Let's view the console. Let's go ahead and change the camera for this peer B. Let's refresh. Okay, so we have two cameras. I will initiate the offer from this side, create offer. So this is the SDP of type offer. I will copy this, go to the other peer and paste. And then I will set remote description for peer B with that SDP that we got from peer A, the offer SDP. From our code, we printed out the SDP, and then I will go ahead and create the answer SDP based on the offer SDP. Let's see what happens. Let me just clear that. Let's scroll all the way up. Now we have an SDP with type answer. I will copy this, go to peer A and paste it there. So now we're pasting the answer SDP. And I will set the remote description on this side with that answer SDP. Print it out as we had done. And then all that is left to do is copy at least one candidate in this case. However, there is one more update we need to make. Let's go up to the on track event of the peer connection. We need to make sure we assign our remote video ref the SRC object with the first media stream from the streams array. Now this happens when a peer receives a remote stream, but we haven't really added our local track or stream to the peer connection when we get user media. So let's go ahead and add the stream or the tracks to the peer connection object. Let's iterate through the tracks of the local stream. And then we add one by one to the peer connection. And that's it. Okay, so now let's go ahead and test our flow again. Open another tab. Let's change the camera. So create an offer from this peer. Let's go ahead and copy the offer, paste it on this side, set remote description, create answer. Let's copy the answer, paste it on this side, set remote description. And then let's go and pick at least one candidate. Let's copy it, clear the text area, paste the candidate and add candidate, and let's see what happens. There we go. So two peers are actually communicating, and that's it for this lesson. See you in the next lesson. Hi, and welcome back to this lesson. Let's recap what we did in the previous lesson. Our goal was to demonstrate signaling of SDP and ICE candidates by doing it manually. So what we did was we manually generated an offer SDP from the offering peer. Then we took the offer SDP and set it as local description on the offering peer. And then we set that same offer SDP as remote description on the answering peer. And then we generated an answer SDP on the answering peer. We set it as local description, and then we took that answer SDP and set it as remote description on the offering peer, and then we exchanged at least one ICE candidate from one peer to the other. And as we had seen, we achieved our goal of getting the two peers connected. Now, WebRTC specification does not define how you should do your signaling, and obviously this way of exchanging SDP and ICE candidates manually is not practical at all. So another way is to use a signaling server. In this lesson, we're going to use socket.io to build a simple signaling server. Let's revisit our logic. If you recall, this was the diagram that we drew and we implemented manually. So now we will introduce a simple signaling server that we'll use to exchange SDP and ICE candidates. So in this case, we generate an offer SDP, set it as local description, then we will send it to the server, and then from the server push it down to peer B. Peer B will set it as remote description, and then we will generate an answer SDP, set it as local description on B, and then send the answer SDP to peer A, and we'll set it as remote description. But at this point, we're still going to use our buttons to initiate the generation of SDP and setting remote description and adding ICE candidates. Okay, let's start off by creating our server-side code. Let's go ahead and create a file called server.js, and I would put it on the root folder. Start off by requiring Express, and then since we're using socket.io, let's require that as well. We're going to use WebRTC as the path. Open another terminal so that we can add Express and socket.io as dependencies. Change folder to web and add the dependencies. Let's view our package.json and verify our packages have been added. Let's now jump back and continue with our code. Let's start by declaring and instantiating our Express app and the port to run the server on. Let's set up a route that we are going to use for testing our server. And let's start listening on the port that we have defined. Let's log to indicate the server is running on the specified port. Let's start our server, node server.js. So the server is now running on port 8080. Let us now test our server and make sure that it's working fine. Type localhost port 8080 and we get hello WebRTC as expected. Now that our Express server is running, let's set our socket.io server listen on the same Express server. The default value for path is socket.io, but we're going to use WebRTC, and basically when you execute the app, this is the sample path that you will see. Notice that we've already added this option up here, so we don't need to add them again. We're going to use a namespace, so let's go ahead and set the namespace, which we shall call WebRTC peers. Now, define an event that is raised when a successful connection is established. A socket will be returned on connection. Let's log out the socket ID. Let's also create an event when the socket disconnects and then just print out a message showing the disconnected socket. Now let's update our client. To establish a connection to our server, we need socket.io client, so let's import it. However, we need to install the package first, so let's do that now. Establish a socket.io connection with these parameters. This call returns a socket object. Do you recognize the parameters? We had defined them while creating the server. Let's create a connection success event on the socket and console log the value sent from the server. Restart the server and also run the application. Clearly, we notice an issue. We're getting 404 not found. Our client is running on port 3000, while our server is running on port 8080. Open package.json and make an entry, which is basically a proxy to our server running on port 8080. That issue is now out of the way. Let's go and make some changes so that we can see the connection happening. I have stopped both the application and the server. Let's start the server first. Okay, so the server is listening on port 8080. Let's go ahead and start the application. Okay, so we notice here the socket.id. The ID of the socket has been logged on the screen. If I refresh, notice what happens. It shows that the previous ID has disconnected and a new ID has been issued with a new connection. So we are sure that the client is talking to the server. So far, we've confirmed the connection is established from the server side, but we haven't yet confirmed from the client side. So let's go ahead and make sure that our client indicates that the connection has taken place. So on the application code, we had created this event, connection success. Let's go ahead and make an entry. Soon after the connection is established, after we log our socket ID, we emit an event and send the socket ID to the client. So we need to restart our server. Let's refresh. Let's view our console. And here we see we got the object back. This is the success object that was sent from the server. Okay, so what we have done so far is when our application loads, it establishes a connection with the server. So now what we need to do is when we press the create offer button, we need to be able to send the SDP to the server. And then obviously from the server to the next peer. So let's go ahead and update our create offer method. Now, after setting local description, we need to send SDP to the server. So let's use our socket and emit SDP and the value of SDP. Now let's go to the server and write this event. When we receive the data, let's log it to the console. Don't forget to restart the server. Okay, let's go ahead and refresh. So we are connected. Let's go ahead and test our create offer and see what happens on the server side. So as you can see, we received the offer SDP. So let's look at our flow again. We have managed to send the SDP to the server. Now we need to implement on the server side to send it to the other peer. Let's go ahead and do that. To send the SDP to the other peer excluding the sender, use broadcast.emit. Okay, let's go ahead and add the event call on the client side. For now, just log it to the console. Now what we have done is that when we click the create offer button, SDP is sent to the server and from the server to the other peer. Okay, let's go ahead and test. All right, let's refresh, open another tab. Click create offer and let's see what happens. Okay, so first we see that the SDP was sent to the server and then see we received on the other peer. So we sent from this peer to the server and from the server to this peer. Let us now set the text area's value to the SDP we just received. The expectation now is when I click the create offer button, I expect the SDP getting populated into this text area. Let's try that. There we go. So we sent from this peer to the server to the other peer. Now that we have the SDP in the text area, we can use the existing code for setting remote description. So let's go ahead and click set remote description and see what happens. So it seems to be working. Now let's go ahead and implement the create answer similar to the create offer. Okay, let's go ahead and test. Okay, let's create offer from this side. So we get the offer SDP. Let's set remote description and then create answer. And we get the answer SDP on this side and we set remote description. Then the only thing left now is the ICE candidates. Let's go back to code and complete the transfer of ICE candidates via the server. Okay, so what we're going to do is when we receive candidates. Okay, so this is on the client side. Let's update our server side code as well when we receive the candidate. And we can broadcast to the other peer. Okay, so when ICE candidates are available, they'll be sent to the server and the server will send to the other peer. So let's go and update our socket event. Let's go and see what the result is after making these few changes. Create offer, set remote description, create answer, set remote description. Now if we go to this server, we see that we've received a bunch of candidates. Now, because we're going to receive more than one candidate, it's better not to put it in the text area. So instead, we're going to create a variable array for holding our candidates. And then when we receive the candidates from the server, we'll add them one by one as they come into the candidates array. Use the spread operator. And then we need to go and update our on-click event for the add candidate button. So we are not getting the value from textref anymore. Let's see what we get in the console when we press the Add Candidate button. Okay, so we received the candidates, and when we press the Add Candidates button, we output these candidates. So now what we need to do is to add these candidates to the PeerConnection object. Let's go and do that. There was a small typo. Let's go and fix that. When we were adding the candidates, okay, so we go back to our add candidate and we're good to go. Okay, so let's test our application. I'll create offer from this peer. So I get the offer on the other peer. I will set remote description. I will create answer from this peer. I have received on the other peer. Set remote description and then add all the candidates. And the application is working fine. In the previous lesson, we managed to get two peers connected using a signaling server by using buttons. Let's just recap what we did. So we created an offer from this peer, and through the signaling server, the offer SDP was sent to the other peer. Then we manually set remote description using this offer SDP, and then we created an answer where we got an answer SDP, and via the signaling server, it was sent to the other peer. And on this offering peer, we set remote description using the answer SDP. And finally, we added the candidates and the connection was established. Let us now have a look at the end result of what we will accomplish in this lesson. We get rid of the buttons for setting remote description and adding candidates, and we've just kept only one button, call. Whoever calls first becomes the offerer. So let's do that from this peer. The offer SDP was sent, and this button has now changed to answer and shows incoming call. And we hit answer, and boom, the connection is established. So we've got rid of most of the intermediate actions taking place. Okay, Let us now go to our code and make the necessary changes. So first things first, let's go get rid of the buttons. So we don't need these buttons anymore. We can also go ahead and remove the associated methods. Let's do a little bit of refactoring. I'm going to create a method called process SDP. And in here, I'm going to move console and the set local description. And I'm going to move socket.emit in there. And then what I'm going to do is I'm going to remove this and remove that and call process SDP and pass in the SDP. And basically, I will do the same in the create answer. But I will be using the socket.emit elsewhere. So I'll refactor this as well. Create a new function, send to peer equals event type and the payload that we want to send. Paste the socket.emit in there, and basically the first parameter would be the event type, either SDP or candidate, and the second one will be the payload. So at least we can reuse the send to peer. So I will use the send to peer in here, SDP, and the object that contains our SDP value. Let us now go and set remote description as soon as we receive SDP from the server. Let's do the same for candidates. And then we comment this out. Okay, let's do a quick test. Create offer and create answer, and the connection is established. So we are good so far. Okay, now let's go back to our code and work on some logic for showing and hiding our buttons. Okay, let me start by declaring some state variables. We don't need candidates anymore because we are adding candidates as they come in. Let's declare a Boolean variable offer visible responsible for show hide our create offer button, which we shall label call. Let's do the same for our answer button with default value false. And I'm going to add status, and we will set the default label to make a call now. Please replace useRef with useState, and we need to add useState in the import. If we look at our UI, we see that our buttons are still there. So let's go ahead and add the logic to show and hide these buttons. And for that, I'm going to add a method just before return. I'll call it show hide buttons. If offer visible is true, then return a div with our call button, create offer, and I will call it call. Else, if answer visible is true, then we return the create answer button and we label it answer. And then we just need to call this method for our buttons logic. Let's quickly jump to our UI and have a look at what we have now. Okay, now we see only one button as expected. Let us also add another div to show our status. We can see our status here just below the call button. When we make an offer, we need to hide the call button. So let's go to create offer method and set offer visible to false. Let's also set status to calling. The other peer will then be receiving the SDP. So let's put some condition here. We check the type. If it's of type offer, then we need to set offer visible to false, set answer visible to true, and change the status to incoming call. Else, the SDP must be the answer SDP. So all we need to do is just set the status to call established. Now we need to hide the answer button when we accept the call. We do that in the create answer Then we set the status to call established. Let's now go and replace the occurrence of socket.emit with send to peer method that we had created earlier. For this lesson, we are now done with coding. Let's go ahead and test. Okay, so let's press the call button from this side. It's now hidden and we're showing calling. And on this side, the button has changed to answer and it shows incoming call. So we answer and we have a connection established.